For this example, we have something that looks a little bit more complicated. We have a lot of things that we want to meet. We want to be continuous and differentiable everywhere except for at -2 and 3 where we're undefined. So I'm going to think about undefined y values way back from test 1. That was a whole or a vertical asymptote would have an undefined y value, couldn't go into our calculator. But then we have a point that can go into our calculator. F of 1/2 is 2. So I'm going to look at the x value 1/2 and plot the y value 2. So we have this point on the graph. And then we have that we are increasing and decreasing on a couple different intervals. It's pretty tough for me to just draw looking at that. So I'm going to make myself a sign chart for this one. There's one option to draw pictures would be to make a sign chart out of what you're given. So a sign chart with that first derivative, it looks like we have 1/2, 3, -2, and 1/2 as numbers in these intervals as I'm reading them. So I'm going to put these in order. So I have -2, 1/2, and 3 to put on my sign chart. These must be the critical numbers. Otherwise, they wouldn't be on our sign chart if they're random test values. So first comes -2, then +1/2, and then +3. So now let's go piece by piece and put it on our sign chart. So we are increasing from 1/2 to 3. So this interval here, we are increasing. And then also 3 to infinity. We're increasing again. And then we are decreasing at -infinity to 2. And then also on -2 to 1/2. So certainly an interesting looking sign chart from the first derivative. And then I have a bunch of information about the second derivative too, which I'm going to make a sign chart out of as well, just because I feel like it's overwhelming to look at all of this at once. I need to start the picture in a less overwhelming way. So I'm going to start it with a sign chart first. So we're given the second derivative is positive. So we're concave up on an interval, and then it's also negative, so we're concave down on an interval. And the important numbers I see in here are -2 and 3, and then still -2 and 3. So for the second derivative, we have 2 possible inflection points at -2 and 3. So looking at what we actually have for those intervals to fill out the sign chart, first thing from -2 to 3, we should be concave down. And then -infinity to -2, we are, concave up rather. Reading that wrong. Bigger than 0 means concave up. From -2 to 3. And then -infinity to -2 is concave down. And then 3 to infinity is also concave down. Then these last pieces, my horizontal asymptote is at y = 0. That means our limit as x goes to infinity was a horizontal asymptote from test 1. As we go far out to the left and the right, we're going to approach the y value of 0. We're not going to go up to infinity or down to -infinity. We're going to be approaching that x-axis. And then we're also given the reason why we were undefined above. It's because we have some vertical asymptotes to put in here. So we have a vertical asymptote at x is -2. So we can denote that with a dotted line, and at x is 3. You don't have to have a dotted line. I just think it helps remind me that, hey, I don't want to cross here. It doesn't have a y value. The y value is undefined. All right, so we have a big picture to put in here. All we have is 1 point. So I'm going to think about what these sign charts are telling me. I'm going to let concavity give me the general shape. So looking at this first interval, we are concave down. So concave down means we have the full U, the left side of the U, or the right side of the U. So we're concave down, but we're also decreasing. We're decreasing, and we're concave down. So when I think about that shape, this third picture is the one that's decreasing and concave down. So I want to draw that on the graph paper, so bear with me 1 moment, don't draw it. Where does it have to go? In this upper piece or this lower piece? Which one is the only one that's going to approach both the horizontal asymptote we're supposed to and the vertical asymptote? Well, this top one as you go out, looks like it's going up to infinity. That's not approaching our horizontal asymptote, so it has to be this bottom one here. It's approaching the horizontal asymptote of 0 and the vertical asymptote at x is -2. So we are going to draw that bottom arrow maybe just a little bit nicer now that I know it goes there. So here's something decreasing and concave down that approaches both of my asymptotes. I don't know if that came out much nicer, but hey, there we go. We have the right shape. Decreasing and concave down. All right, so next slot we have is always concave up. So we have something concave up, so it could be a full U, could be just the left side of the U, or it could be just the right side of the U. So I want to consider what's happening with the first derivative. So the first derivative tells us that we're decreasing, then increasing, and concave up. So which graph is decreasing and then increasing, but always concave up? It would be this one. So we still want to be decreasing and then increasing. Sorry, I cut out for a second there. So decreasing and then increasing, and we want to cross to that point that we're given. So there's something decreasing, -2 to 1/2, just like we were supposed to be, and then increasing 1/2 to 3, just like we were supposed to be, and we're always concave up. So far we've done quite a bit of this. We're decreasing -infinity to -2 while being concave down. We have one last piece that is supposed to be increasing and concave up. So we could be looking here. I like looking at the sign charts personally. So I'm going to look at the sign chart. I want to be increasing while being concave down. So I'm going to draw my 3 U's again. Full U, left side of the U, right side of the U. I want to be increasing and concave down. I want to look like that middle picture. Increasing and concave down. So bear with me one moment. We could put it up here, or we could put it down here. We can't put it both places because it's a function, so it only has one y value for each x value. So as far as the placement, which one does it have to be if we want to approach both our vertical asymptote and our horizontal asymptote? These both approach our vertical asymptote, but this one does not approach y = 0 like it's supposed to as x goes out. So we must have to draw that bottom picture. I can try to draw it a little bit neater on here. Now that you're ready to draw it too, we are increasing, but we are oriented downward. We're approaching our vertical asymptote and our horizontal asymptote. Definitely complicated, but I also feel like drawing the sign chart helps. We got that last piece where it was increasing through to infinity and concave down through to infinity. So this looks like a solid sketch, although it could look a few different ways since there are more things that we had to meet, more conditions, then it narrows down what the graph could look like. So not as many possibilities for this.